Geneticist Turi King had one of the toughest jobs. She had to find fragile DNA in bones that were 500 years old.
Actually, what you could do is if you just hold it in place.
When you're working with ancient remains, you have to be extremely careful about contamination. One of the biggest issues with ancient DNA is contamination with modern DNA. So what I was ensuring was that while excavating and while lifting the skelly, Joe was working under extremely clean conditions. When we were looking at the skelly, we were fully garbed up in the suits. We had face masks, we were double gloved.
To ensure an accurate DNA result, each step had to be double-checked at 2 separate labs.
The skeletal remains were actually in extremely good condition. Now, it doesn't necessarily guarantee that you'll be able to get ancient DNA out of them because it completely depends on the soil conditions. And what I was hoping to get were teeth, and that's because they're the most likely bit to remain. They're usually very well preserved. So what you do is you take the teeth and you take them into a clean room, you clean them extremely carefully, and then you crush them into a powder. And then from that you try and extract the DNA from that powder.
Sounds simple, but ancient DNA is broken into thousands of tiny fragments. Piecing them together takes months of painstaking work.
Right, well, what I've got here is I have got a spit sample from Michael Ibsen, and that contains an awful lot of his DNA. It's got a lot of his cheek cells in there. And what I'm going to be doing is I'm going to be taking some of this and extracting his DNA from it, and then I'm going to be sequencing his mitochondrial DNA and comparing it with any mitochondrial DNA we can get from the skeletal remains.
Unlike the skeleton, Michael's DNA took Turi a matter of days to analyze and sequence because it was in so much better condition.
So this is essentially part of the sequence of Michael's mitochondrial DNA. And this is actually from my dad. And what you'll see is that not everybody has got the same DNA sequence. You can see that there's difference between the two of them. So my dad here has got a particular sequence and Michael has got a slightly different one. So that's how you can tell mitochondrial DNA sequences apart from one another. And what I'll be doing is trying to get the DNA sequence from the same region in the skeletal remains and then comparing the two sequences. And what we're hoping is that we'll get a perfect match.
I genuinely don't know what the DNA result is. Michael, thank you. Hello.
Hello. Yeah. So,
if you look at the DNA of Michael and you look at the DNA from the skeletal remains, there's a match.
Wow.
Blimey!
wow.
Looking at the sequences, the match was identical. Richard and Michael share one of the rarest types of mitochondrial DNA called haplotype J1C2C. It's carried by just 1 to 2% of the population. This made the match even more reliable.
As I started to see the first sequences come back and seeing that it was a match, and I just went really quiet. It was very profound.
Turi also revealed that she had managed to isolate a Y chromosome, proving that the skeleton was male.
What was so exciting about the moment of being told was it meant that we could actually say beyond reasonable doubt that we'd found Richard III. Whereas without the DNA, it might have been something like the balance of probability is that it's Richard III.
To reinforce the genealogical research, Kevin Schurer and Turi King obtained a DNA sample from another female line relative of Richard III. They also matched.
And I can now tell you there is a DNA match between the maternal DNA from the descendants of the family of Richard III and the skeletal remains that we found at the Greyfriars Dig.
Richard's skeleton is now undergoing further scientific tests to tell us more about his life. Turi King is analyzing his DNA in even greater detail, investigating his Y chromosome to check the male line of descent, and searching for evidence of hereditary disease. The skeleton has more secrets to reveal.